I hope you all have studied this in your O-levels as well. So what is a set? Yes? No one knows?
It's an organized collection of objects or whatever it is.
Okay. What else? Yeah, some says grouping of like data. Yes, grouping. Yeah. What else? Organization is also correct. What else? Is there any other property? Set of collection. Okay. What else? There are some other properties. What are those? Same kind of element. Okay. Collection of distinct objects. Yes. Tushan said it's a collection of distinct objects. Yeah, we can't repeat the same element again and again in a set. Okay, that is the smallest element that can, smallest set, collection that can be represent the set. Okay, if we have 1, 1, 2, what is the set? If these are the elements, what is the set?
No. No.
1 and 2. Don't repeat the same element again and again. Okay. So let's move to the definition. A set is a collection of distinct objects. Okay. And if we are going to represent a set, we can represent it as a wording, or we can represent it as a graphical way, or just the elements. Okay, whatever it is, we can represent the element set in 3 ways. Okay, so here we can represent sets in nature by group of objects such as a stock of seeds, collection of flowers, group of farmers, group of cultivated items, etc. Okay, it depends on the characteristic of object. Can someone please tell me an example for a set rather than this? Example of a set.
Recording in progress.
Yes.
Districts.
Set of bank accounts, yes. If you are sending the answer, you can send it to everyone, okay?
Even numbers less than 20.
Yes, even numbers less than 20, okay. If you are considering just even numbers, is it a set? You particularly mentioned that the even numbers less than 20. If I am saying we are considering even numbers, is it a set? Yes?
Yes.
Yeah, it's a set. The only the difference is number of elements.
Infinite number of
Infinite number of elements. And when you are considering, if you are telling a border, that means you have a finite number of elements. Okay. So here we have a collection of distinct objects in a set. So we say a set is a well-defined collection of objects. Okay. Well-defined means the object follows a given rule or rules. As you all mentioned, even numbers. If you are considering even numbers, it's the rule for the set. Even numbers less than 20 means even number is a rule and the second rule is less than 20. Okay, so likewise, if there are, when you are defining a set, if there are many rules, you have to follow all of those. Okay. Then, okay, these are some examples. Elements of a set can be either number or any name or any word or any letter. Okay, so let's move to the notation of sets. Sets are usually denoted by the capital letters. Okay, capital letters. There are some specific letters that we are not using for some sets. Those are U. U means the universal set. We will study about it within few minutes. Okay. So other than U, we are using other capital letters to represent a set. Okay. And the elements of a set are all simple letters. Okay. If you are writing a general one, it can be any simple letter. And let X be any set of object and simple X be a member. Member means the element. Okay? Element of a X. If X is a element in capital X, we denoted it with this symbol. This symbol represents the element. If X is not belongs to capital X, then we represent it as the element and cut it off. Okay. So this represents X is not an element in capital X. This one represents X is an element of capital X. Okay. So if I'm considering capital A as the prime numbers. Okay, I hope you all know about prime numbers. A is the set of all prime numbers. 2, what can you say about 2? Is that an element in capital A? Yes. Is it an element in capital A?
Yes.
Yes. So we have to represent it by using this symbol. Okay. What about the second one?
That's not a
It's not a
element.
why? Why is that? Yeah. Why it's not a prime number?
You can divide that another 3 or 2.
Yes. There are 3 sorry, not 3. Exactly, there are 4 factors for this. Okay, so that this is not a prime number. So we have to represent it by writing the symbol, element symbol and cut it off. Okay. So already I mentioned that we can represent a set by representing its element or the description or the graphical way or pictorial way. So there are three methods to represent the set. First, we are using the tabular form or the roster form, and then the set builder form or rule method. Set builder form or rule method. This word says, what is it? You have to mention what are the rules that need to satisfy the element. Okay. So first of all, let us consider the tabular form. Tabular form means in this method, we list all the elements of set separating by means of commas. Okay. If you have 2, 3, 4, 5, we have to separate it by using a comma and write it inside the curly bracket. Okay. This is the tabular form. You have to represent each and every element. Okay. If it's an infinite set, what you have to do? Let's say real, integers, positive integers. You can use 3 dot to represent its continuing. Okay. So since this is also tabular form, just give me a second. Right? Okay. Then can someone please tell me another example for tabular form? Or just type it on the chat. Yes. Some example for tabular form. Yeah, odd numbers, even numbers, correct, but is it the tabular form? For the tabular form, you have to represent the elements. Yes, I'm getting some messages in chat. Yeah. If you are saying it's a odd numbers, or if you are saying it's an even number, it's not the tabular form. You are telling the description or the rule. Okay, so surely for the tabular form, there should be the elements. Okay, when you are representing the set, you have to represent it by mentioning the elements. Okay, the set builder form is instead of listing all elements, we can write the set by some special property or properties that satisfy the elements and write it as like this. Okay, here capital X, okay, is the set. Simple X is the element which satisfy Px. Or in other words, capital A, simple X is the element X. This X has the property of capital Px. Okay, here we have an example. Capital X is equals to, the elements are in a way such that X is in between 16 and 2, and X is equals to 3n, where n is an integer. Okay, can you please tell me the tabular form of this? If you can understand these properties, you would be able to tell the elements of this set. X is equals to, capital X is equals to, can you all understand this rules? If not, you can tell me. This each and element x, okay, exists in a way such that it's a multiple of in some integer. But that integer, that x should be in between 2 and 16. So to write the multiple of 3, we can have 3, 6, then 9, 12, 15, 18, 21. These are the multiples of 3. But there is another restriction such that x is greater than 2 and less than 16. So the element should be this. So if you want to represent it in set delta form, you have to write down the elements. Okay. When you consider this description of the set, here you have a comma. That means you have to satisfy each and every rule. Okay. If we have mentioned here O, then that's fine. You can consider either this rule or either this rule. But the comma represents the and one. You have to consider each and every rule in this set. Okay. Then yeah. Do you have any questions? Okay. Then we'll go to some special sets, finite and infinite set. We already talked about this at the beginning. What is a finite set and what is infinite set? Yes? What is a finite set?
Limited number.
Limited number of what?
It contains a finite number of elements.
Okay. For the infinite set?
We can't count the element.
No limit in the element in the set.
There are infinite number of elements. Okay. Do you know what is infinite number of elements? When you are counting, okay, if you can end at a point, that means it's finite. But if you are counting and there is no end, that means it's a infinite. So if you can count the elements in a set, so we can say it as a finite set. There are some examples for this. A set of prime numbers less than 20. It's a finite set. And if you are considering all prime numbers, what is that?
Infinite set.
It's an
Infinite set.
infinite set. Okay? Finite and infinite. You have infinite set. Consider the second example. Is this correct? Is this correct? No. Why? If it's not correct, then what's the reason? It's repeating. But here, no elements are repeating. You have to list down the vowels that occur in the word. Okay?
Correct.
Yeah. Yes. Someone says the element should be in lowercase. Yeah. When we are considering the general ones, we are writing the letters or elements in the lowercase. But this specifically says these in these two words, you have to identify the vowels. So you can't change. If this is in the uppercase, you can't change it to lowercase. It's specifically given. Okay? So then they should be anyhow capital. The wordings are given in the capital letters, so you have to write it the capital letters. And when you are considering the vowels, the E, repeating again and again, there are 4 E's. But when you are writing the set, you can't repeat same element again and again. So that this is correct. Okay? This is correct. You can't repeat the same element again and again. So that this is, when you are counting number of elements of B is equals to 3. So that this is also finite set. Okay? So then C said X is the element. X is the divisor of 72. So you have to list down all the divisors of 72. If you missed at least one divisor, then that is not correct. Okay? So the number of elements of a set can be represented using this notation, which I wrote earlier. If the set is capital X, the number of elements of the set can be represented as simple N inside a bracket, the letter for the set equals to number of elements. Okay. If a set having infinite number of elements, we call it as an infinite set. And what is the, if X is an infinite set, what is it? How many elements are there?
We can't count infinity.
We can't count, so that should be infinity. Okay. For infinite set, there are some examples. This should be infinite. Okay. Infinite set, the set of all natural numbers, set of all real numbers. Okay. So let me tell you another one. Let's say A and B. Those are two different sets. You have to tell me whether it's a finite one or the infinite one. Let's say X is a real number and X belongs to 4 and 2. Is it a finite set or infinite set?
Finite.
That's it.
Is it a finite set? Yes. If you are considering real numbers between 2 and 4, okay. Those who said it's a finite set, can you tell me the elements? Yes.
3.
3, okay. Is that so? What about 2.5? And 3.1, 2.1, 2.01, 2.001. Likewise, we have infinitely many real numbers in between 2 and 4. So, capital A is not a finite set. There are infinitely many real numbers in between 2 and 4. So, what about capital B? What about capital B? It's a finite set. Then only 3 is the element. Okay? Is that clear? Yeah. Then here you have a same kind of example. X is a real number and real number in between 10 and 11. There are many. Okay. There are many real numbers in between 10 and 11. And if you replace this by capital, integers, how many elements are there?
Only one.
Only one?
There are no elements.
What you said?
No elements.
Yes, there are no elements. In between 10 and 11, there are no integers. Okay. And then cardinal number, I already mentioned that the number of elements. Okay. So null set. What is a null set? The previous example, if we replace this by integers, no elements, nothing is there. So if a set containing no elements is called as a null set, or we call it as empty set. Okay. The null set is denoted by this symbol or just only the curly brackets. Okay. If there's no element, we say the cardinal number is 0. It's also finite number, so that null set is a finite set. Okay. Then what is this? What is this?
No elements.
No elements. Others?
The element is the null set.
Yes. Others? Any other different answer? What is the cardinal number? Yes. What is the cardinal number of this set?
1.
1.
1. Is this correct? Is it a null set? Null set is either this one or this one. Just only curly brackets. If you have both, means this represents the set notation and the element is null set. Okay?
0.
So, in some papers also we can see some students are writing null set as this. This is not correct. Null set is either this one or this one. This represents a set with one element. The element is this null set. Okay. Okay. Rather than this, can you tell me an example for a null set? Example for a null set? Yes. Negative numbers between 1 and 10. Integers between 0 and 1. Yes, those are null set. If we have another special set, we call it as a singleton set. Singleton set means the set containing only one element, like this. This is a singleton set. Okay. If the set containing only one element, so let's say the set X, then the cardinal number is always 1. Okay. The example is even prime numbers. 2 is the only even prime number. Okay. So if we have a set with simple A, this is also singleton set. Please tell me another singleton set. Example for the singleton set. Yes. If we are considering this quadratic equation, the solution of this quadratic equation are, what are the solution for this quadratic equation? What is the factorization of this? X minus 1 whole square is equal to 0. Therefore, we have x equals 1 twice. The same solution we are getting twice. But when you are considering the set, that contains only 1. Okay. So this is a singleton set. If I am saying we have 2 equal sets, what are the conditions that need to satisfy? Okay. Any other answer? Any other answer? Same elements. Number of elements should be equal. Okay, if I'm saying I have 1 and 2 in a set and 2 and 3 in another set. Are they equal sets? No.
No.
Then if we have equal number of elements in 2 sets, we can't say it's a equal set. The equal set means 2 sets A and B are said to be equal if they consist the same elements. Okay. If at least one element is different, so we can't say it as a equal set. Earlier, some students said the element should be identical. Oh, yes. If we have 1, 2, 3. This is equals to this. Either maybe order is changed, but same element. In other words, we can represent it as A equal B if and only if X is in A implies X is in B and X is in B implies X is in A. Okay, so only if both sides are satisfied. All the elements in B is in A and all the elements in A is in B. We can represent the equal sets in another different way after we have studied the subset of sets. We'll go for that. There are some examples you can work on that. Okay, can someone please tell me the answer for this? See? Check whether these three sets are equal or not.
Yes. No.
Yes? No. Why?
No.
Why is that?
They are equal.
Hmm?
They are equal.
Yes, they are equal. Let's consider we have W in all three words. Then we have O. Okay. Then we have L. Finally, we have F. When you consider the remaining letters, already we cut it off. So we have only 4 letters, W, O, L, F. So that these are equal. What about this? Are they equal?
No, ma'am. No, ma'am.
Why?
Whose character I?
Because of this character I, yes. The set B doesn't contain I. So these are not equal sets. Then let us move to the subset of a set. If A and B are two sets, then B is called a subset of A if every element of B is also an element of A. Okay? We represent it as B is a subset of capital A. All the elements in B is in capital A. Okay? So we call A is the superset of B as well. B is the subset of A and A is the superset, the larger set. The proper subset of a set B is said to be proper subset of set A if every element of B is an element of A and there exists an element of A which is not an element of B. So we are representing it as a B is a proper subset of A. If you can understand these two definitions, can you please tell me what is the difference of a subset or a proper subset? What is the difference? Yes, set A contains more elements than set B. At least there is a one element in A which is not there in B. So we can represent it by using this symbol without mentioning this equal sign. Okay. Okay. Here, these are some examples. 1, 2, and 5 is there in capital A, and 1, 2, 3, 4, 5 is there in capital B. Okay. Then we can see these three elements are there in capital D, but 3 is not there in capital A and 4 is not there in capital A. So that A is a proper subset of B. There are 2 elements in B which are not there in capital A. Okay. What about this? All the natural numbers and all the integers? Yes? Is it a proper subset? Yeah.
Yes.
All integers is a
Natural.
what you say? All integers is the largest set than set of natural numbers. Okay, when you consider minus integers, which is not there in natural numbers. So it's a proper subset. Okay. So when you consider the universal set, someone asked about what is natural number. Natural numbers are 1, 2, 3, 4. All the positive integers. In some books, you can see natural numbers including 0. Okay. There are some books, those books define natural numbers as including 0, positive integers including 0. Okay, then the universal set, a universal set is a collection of all objects in a particular context or theory. Universal set is denoted by capital U. When you are considering different sets, the universal set containing all the elements that are in those sets. We are saying it's a larger set in these. Okay. All other sets are proper subset of universal set. Okay. So, okay. Replace star by using subset notation or not a subset notation to make the statement correct in the following. What can you say about the first statement?
Not a subset.
Why?
3 is not there in the next one.
But when you consider these two, are they sets?
No, ma'am.
Why?
Brackets.
Yes, brackets are different. In order to represent set, you have to use the curly bracket. But here you have normal brackets. So these are not set. These are tuples. You can't use either any of these. Same for the part B as well. Okay. So what about this? C part. What about C part? What are the elements of this C part? You have to repeat. Yeah. Okay. Then what about this? Can we use either this symbol or this one?
No.
Not a subset. We can't use this side or either. Not a subset. Okay. Then let's move to the Venn diagram. This is the pictorial way to represent the set, or this is the graphical way to represent sets. Normally, when you are considering a universal set, we represent it by using a rectangle or a square. Okay, this is the universal set. Inside that, we are drawing some sets, okay, according to their elements. Always, if you have a set and you have a proper subset for that, you have to draw that inside the larger set. Okay, if B is a proper subset of A, so always you have to mention that set inside the larger one. What happens if you draw like this? Is it a subset? A and B? No. Okay. Remember those characters while you are drawing the Venn diagram. Okay. So, if there are two sets which are not comparable, then neither of X or Y, this should be Y, is a set of the other. That's what I have mentioned here. There is no intersection in between those two circles. Okay. These are, we don't have any intersections or we don't have any common elements. Okay. There is no any other common elements for these two sets, so that we can't go like this or like this. If we don't have any common elements, we call those sets as disjoint sets. Okay, either X is not a subset of Y and Y is not a subset of X. Okay, if you have common element, then we can have the part for the intersection of common area is therefore both X and Y. Okay, here also, what can you say about the subset? Is that X is a subset of Y or Y is a subset of X? No.
No.
Both are not subset of each other. But there is a common area to represent. Okay, so we call that area as the intersection area. Okay. Then complement of a set. Always we know that every element is a subset of universal set. Okay. The set contains of the element in the universal set but not in the set X. Is called the complement of set. If we represent, let's say this is X and this is the universal set. The complement of this set can be represented as this shaded region. All the elements in U but not in capital X. Okay. The complement is represented by X dash, or we represent it as X. Okay. And then we'll move to the operations on set. Is that clear up to now? Is that clear up to now?
Yes, ma'am.
Okay.
Yes, ma'am.
Then let's move to the operation on set. There are few operations on set. If you can understand the concepts in the previous topics, you can easily identify the elements in after using this operation. There are unions, intersections, and different likewise complement. All those are there. What is a union of set? combination of okay, what else? Distinct element here. Others? Others? Is there any different answer? Yes? If you are considering two sets, A and B, the union, the elements in the union is either in A or in B. As the rule, you can't repeat the same element. Okay, so that if you are having these two sets, the phi is the intersection, so phi is the common element. So if you are writing the union set, you can't repeat this phi again and again. All the elements in A and B. Okay. So if you are considering this example number 11, A consists of 1, 9, 16, 18, 21, 22, 23. B contains 9, 18, 21, 24. What is the intersection? Union. What are the elements in the union?
Twenty-two, 23,
Is that so? Up to 23?
24.
24. All the elements. Okay. So 1, 9, 16, 18, 21, 22, and 23. 22 is not there in 22 is not there in capital B, and 23 is not there in capital B, and 24 is not there in capital A. But all the elements should include in the union. If you are representing it in a Venn diagram, you can represent like this. The colored region is the union of A and B. Okay? And then the intersection. Intersection is the common elements of those two sets. Let A and B be two given sets. Then the intersection of capital A and B is the set of elements which belongs to both A and B. Okay? In other words, intersection of A and B is the set of common members of A and B. If you consider these two examples, A is the 6, 8, 9, 10, 12, 16, and B is 2, 5, 6, 10, 16. The intersection is the common elements 6, 10, and 16. Okay? To represent it in a Venn diagram, the common region is represent the intersection of A and B. Is that clear?
Yes, ma'am.
Yes.
Okay. Now I already explained about the disjoint sets. Okay. Disjoint sets, you can't draw it like this or like this. Using the operation of sets, can you explain the disjoint sets? Either using union or intersection, can you explain disjoint sets? Yes? union is empty. Is that so?
Intersection is empty.
In chat, I can see union is empty. Not the union. Intersection is empty. You can see in the definition also, intersection is empty. If not, you can go like this or like this. So, always if the word doesn't appear in a question, maybe it doesn't appear in a question, you have to disjoint it. But if we mention it as A intersection, B is empty, you have to identify that that's a disjoint set. Okay, so if you see the figure only also, you can identify whether it's a disjoint set or not. And then the difference of set. Difference means, let's say we are considering the difference of A and B. A minus B. A difference B. When you have a set A and you have another set B, what is the region? What should be the A difference B region? Is that 1? Is that 2? Is that 3? If this is A. Which region represents A minus B?
One.
1 only.
Yeah.
Someone saying at 1 and 3. Is it correct? The correct answer is 1. In the difference set, it should be in A and not in B. Okay? It should be in A and not in B. So, this should be the correct region. And remember that we can see in some answer scripts, so students are writing if we have these two sets, they are getting the difference as 9 minus 1, 9, 12 minus 12, 15 minus 14, likewise, they are getting the difference of each and every element. That doesn't represent the set difference. So, set difference means if you want to get A minus B, you have to remove all the elements which is there in capital A and capital B. The common element should be removed from capital A. That represents the difference. Okay? So, yeah, in chat, someone says 1 and universe. Is that universe? If you are considering the universal set, okay, what happens? Is that in capital A? Yes. If you are considering the universe, that represents the complement of B. Okay? Not the difference. You can't take the universal set to represent the difference. Okay? So let us see some representation of A minus B by Venn diagram. If you have an intersection, okay, so this is remove all the B elements, these elements from A. So this region represents A minus B. And here, B is a proper subset of A. So once you remove all the elements in B, this is the region that represents A minus B. And what about this? These A and B are disjoint sets. There is no common element. No common elements means we don't have to remove any element from A. So the whole A is the A minus B. In this case, A is equals to A minus B. Okay. But in the last figure, there is no any shaded region. Is that correct or it's a mistake?
It's correct.
It's correct.
Why?
Because A is proper subset of B.
Okay. Then? Yes. This is correct. There's no elements in A minus B. Because A is the proper subset of B. So if you are removing all the B elements from A, there is nothing. Okay? So this is the difference of set. Can you understand up to now? Yes? When you see your past papers, you can see there is a question for set. So you have to learn about these sets very carefully. Okay? So then we can move to the laws of algebra of sets. You have to remember everything. The identity law is, we know that U is the universal set and A is the subset of universal set. And A union empty set. Is that A? Why? Adding nothing to A. Yeah. You are adding nothing to A. So that's A. And when you are getting the intersection also, with universal set, you are getting the intersection of A. What is that?
The common elements is A.
Intersection. So these two are the identity laws. Then we have idempotent law. A union A is again A intersection A is again A. In commutative law, either for union or intersection, you can interchange the sets. Okay, this is the commutative law. You are interchanging the set. And then associative law. Here, you have the intersection only. Union only. But there is a bracket. You can first either take the union of A and B, and after that take the union with C, or you can take the union of B and C, after that take the union with A. Okay, this is the associative law. Remember that they are the same operator. Okay. The second identity law is with intersection, again same operator. Change the order of the bracket. And when it comes to distributive law, can you see the difference of associative law and distributive law? There's a bracket, but we have two different operators, union as well as the intersection. Okay. If you have this kind of a expression, so you have to take A union B. After that, intersection A union C. A union B, the middle operator comes here. Then A union C. The other way around, if you have A intersection, B union C, you have to take it as A intersection B. This operator comes here, and this comes here and here. Okay, this is the two different distributive laws. Don't confuse with associativity law and distributive law. And then we have the De Morgan's law. De Morgan's law means first we took the union of A and B and then take the complement. It's same as take the complement of A and take the complement of B and get the intersection of those two. Okay? Union becomes intersection. Intersection becomes union. Okay? Those are the laws of set algebra. Can you please tell me the elements of A intersection B? For this example, 3 and 4.
3 and 4.
Okay, B intersection C?
4 and 5.
4 and
5.
4, 5. B minus C?
3, 7, 8.
Huh?
7, 8.
Who said 3, 7, 8?
Only 3.
Only 3. In B minus C, the element should be in B but not in C. Okay? Is that clear?
Yeah.
By the definition, okay, in B minus C, the element should be in B but not in C. You have to remove, first of all, you have to consider what are the common elements of B and C. These are the common elements of B and C. Then remove this from B. No need to think about 7 and 8. Okay? Is that clear? Yes?
Yes, ma'am.
Okay, then. This example says verify the following. No need to mention this as this is the associativity law and this is the commutativity law. If you have this kind of a question, verify the following means you have to calculate or you have to get the elements of this one and then say whether this is correct or wrong. The sets are defined. So using this only you have to verify, not with the rules. Okay. So the shading part also hope you can do it by your own. Please follow up all the questions. Okay. Then application of sets. We have when you are considering real world problem, you can identify many sets. There are many set operations that we are applying in real life problem also. So for that, you have to know some basic things in set application. First of all, we need to study about the number of elements in A union. Okay, when you consider, let me draw these two. This is A. Okay, and this is B. And if I am try to color A set, this represents A. Okay, and I am coloring the set B. What is A union B? What is A union B? Total color shaded region is represent the A union B. Okay, if I am considering N A union B, number of elements in A union B is equals to number of elements in A plus number of elements in B Is that correct?
Minus
Minus
intersection.
number of
Intersection.
A intersection B. Can you understand why we are deducting number of elements of A intersection B from here? Yes?
It is there in both the
Yeah.
sets.
Yeah, if we are considering the green color one, it represents number of elements in A. And if we are considering the blue region, it represents number of elements in B. But this region comes twice. So to take this everything, we have to remove the middle part again. That's why number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. You have to use this in order to do the calculations using set. If you are considering two disjoint sets, what can you say about this formula? For two disjoint sets,
A intersection B will be 0.
yes, this part will be 0. So the formula comes as number of elements in A union B is equal to number of elements in A plus number of elements in B. Okay. So remember where you can use this and where you can use this. No need to remember this one exactly, because if you know general formula, you can use it for the disjoint set as well by just replacing number of elements in A intersection B as 0. Okay. So here consider this example. In a society of farmers, 153 farmers cultivated paddy, 78 farmers cultivated vegetables, and 35 farmers cultivated both paddy and vegetable. Find the total number of farmers in the society. Can you understand this question? If you are considering 153 farmers cultivated paddy, let us represent this as P and this as Q, vegetables. If I mark it inside this region, is that correct?
No.
No. That should be comes as the total number of farmers that cultivated paddy. And then 78 is number of farmers cultivated vegetable. This whole region represents 153 and this whole region represents 78. Now then there's another one, 35 farmers cultivated both paddy and vegetable. Therefore that should be the intersection. Okay, intersection represents 35 farmers. After that only you can identify these numbers. How to get these numbers? 153 minus 35 equals to 180. 78 minus 35 is equals to 43. Okay, 118 represent what? It's the number of farmers
Who cultivated
Only cultivated paddy.
Yes. This one?
Only cultivated vegetable.
Yes. There are 43 farmers cultivated only vegetables. Okay, now what the question asks? Find the total number of farmers in the society. How to find it? If you represent it in the Venn diagram, then how to find it?
118 plus 35 plus 43.
118, 35 and 40. Okay. Then if you are using this formula also, you can easily identify. Total number of farmers represent number of P union V, and you have number of farmers who cultivated paddy, it's NP, and number of farmers who cultivated vegetables, NV, minus the intersection is given. Isn't it? Easily you can apply this formula into this question. Okay. So the formula for N, A union B union C is this. You can easily figure out using the Venn diagram as well. Number of elements in A union B union C is equals to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C. This is the formula for 3 sets. Okay. So please work out on these questions. I think that's all about set theory. And there are some past papers in your LMS as well. Please work out on those questions as well. Then you can easily identify which kind of question that we will ask for the final examination. Okay, then let us move to the inequalities. Do you have any questions regarding set theory? So then, yes, what you said? No, you have the final exam at the end of first year. You have the final exam with the second semester courses. Okay, this is a 1-year course. Okay, then shall we move to the inequalities? If you don't have any questions, we can move to the inequalities. Okay. What do you know about inequalities? Yes. What do you know about inequalities? Just give me an example. Last time also we studied some basic things about inequalities. Yeah, algebraic expressions with the symbols, which Akhtar gave in the chat. Yeah, those notation is included in the inequalities. Just give me an example. Unmute yourself and tell me an example. Okay. In terms of words, without expressing it as an algebraic expression.
Greater than or lesser than?
Yeah. Example?
3x minus 2 is greater than or equal to 5.
Yeah, that's also an algebraic expression. No?
It is greater than
In real world situation, how we are using inequalities? Yes?
Or greater than 3.
Yeah. Marks. Yeah, exactly. Why? The eligibility criteria. Also in real world life, we are using that. You have to get at least this much in order to eligible for the final exam. Okay, likewise, you can apply that in the real world problem as well. Are you all studying Java? Yes, Java or C++? Yes. What are the applications of inequalities that you are using there? Yes. What are the inequalities that you are using?
Statements.
Repetitions, yes. Repetitions that you are using. When you are creating a loop, you have to restrict it, no? Otherwise, it will run for the infinitely many number of loops. So in Java, if you are writing it as starting from 1, you have to mention either 1 should be less than 6 or something, or you have to mention where to stop. Okay, so there also you are using inequalities, but you don't know that you are using inequalities, but with the practice you are using the same, isn't it? Okay, let's see. If you have two different real numbers, okay, if you have any real two real numbers, okay, A and B. This A and B are real numbers, and we can write it either this way or this way or this way. Any real number satisfy either any of these cases. Okay? Are you all agree with me? Yes?
yes, miss.
Any real number can be written in either any of this form. Okay? So, normally when we are considering inequalities, it comes with greater than equal sign, less than or equal sign, less than sign, greater than sign, or everything. So, we are representing it in a real line. If we have a number x less than or equals to a dash, we have to represent it with the colored circle and you have to mark the region. Last time I explained about these basic things in the first theory discussion. So let's straightly move to the important results. Consider any A, B, C real numbers. If you have A greater than B and B greater than C, B is greater than C, then straight away you can write it as A is greater than C. Okay, that's the first result. And when you consider A greater than B, okay, and you are considering the same quantity, we are adding the same quantity to both sides. Can you remember solving equations? If we have A x plus 5 equals 2 or something, you can add the same quantity to both sides in order to keep the sign same. Okay, likewise here also, if you are adding the same quantity to both sides, the sign won't change. Okay, so, and now we have A greater than B, and then there is a real number, a positive real number C. Okay, this is really important. If you are considering positive real number C, now if you are multiplying both sides by C, the sign won't change. A greater than B, I am multiplying with positive C. Okay, so the sign won't change. If you are considering A greater than B and a real number which is a negative real number, and if you multiply both sides by that real number, the sign interchange. Okay, can you see this? Earlier we had A is greater than B, but now AC is lesser than BC because of C is a negative number. Okay, and let's show another example. We have, for the fifth rule, we have 3 and 2. Which is the largest number among these two? 3. 3. So 3 is greater than 2. What about 1 over 3 and 1 over 2?
One
Which is
or
the
two is
largest?
greater. 1 or 2 is greater.
So, if we are getting the reciprocal, this sign changes. A is greater than B, then 1 over A is lesser than 1 over B. Okay? And then the same as the multiplication, if you are considering A greater than B and C positive number and divide both by positive number, won't change the sign. Like the same as the multiplication. If you are multiplying with a positive number, sign won't change. But if you are dividing by a negative number, the sign interchange. Here also, if you are multiplying with the negative number, sign interchange. Those are the basic important rules of inequalities. Is that clear?
Yes,
Is that clear up to now? Yeah, okay. Then inequalities in one variable. Okay, now there are some inequalities and you have to get the solution for these inequalities. Solution may be a one number if you are considering number of integer line. Okay, if you are considering a real number line, there are infinitely many solutions. Okay, so first of all, consider this. X minus 3 and x plus 2 is lesser than 0. Can someone please tell me the answer? If you already know about inequalities. First of all, yeah. Yes. Yeah. First of all, if you have a factor, then that's fine. We can easily get the answers. If you don't have any factors, you have to break it into factors. Otherwise, you can't say what are the solutions. But when you consider the second example, you can't say the solution straight away. Okay, so you have to break the expression into factors. That's why we have the factorization in our first unit. Now, consider this. What are the solutions? If you replace this, if you neglect this inequality and make it as an equal sign, what are the solutions? X
Minus.
equals minus 2, yeah, and x equals 3. Okay, so at around these 2 points, the sign changes. So these are like our critical points. Around minus 2, one side is positive, one side is negative. Around 3 as well, one side is positive, one side is negative. So now we have to think about the which region that satisfies this inequality. Now we found the critical points minus 2 and 3. Since we have less than or equal sign, we can include this minus 2. By it can be included. What happens at x equal minus 2? Yes. What happens to this inequality? Is it satisfied? Yeah, that becomes 0. If that becomes 0, that satisfies the inequality, isn't it? It's less than or equal to 0. So that's satisfied. So we can include these 2 points to our solution. Then what about this region? Now we have region 1, region 2, and region 3. Now we have to think whether this region satisfies the inequality or this region satisfies the inequality or this region. Okay, we have to identify. How to identify that? The easiest way? Take any real number which is lesser than minus 2. Yes? Take any real number which is lesser than minus 2. Give me an example.
Minus 3.
Yes, minus 3. Then what happens to the first factor?
Minus 6.
Minus 6. Then what happens to the second factor?
Minus 1.
Minus 1. Minus 6 times minus 1 is equals to?
3.
Yes, minus 6 times minus 1 is equals to?
6.
6. Is it positive or negative?
Positive.
Positive. Then can we include the region 1?
No.
No. Then we have to neglect that part. What about the second region?
0.
Yes, we can take any number in between minus 2 and 3. So when we take 0, what happens to the first factor?
Minus 3.
Minus 3. The second one?
2.
2. The multiplication is?
Minus 6.
Minus 6. Is that satisfy the inequality?
Yes.
Yes. So that we can mark this region. What about the region 3?
4.
Okay. When we take 4, 4 minus 3? Yes?
1.
1.
1. 4 plus 2?
6.
6.
6.
The multiplication is?
6.
6. Is that positive or negative?
Positive.
Is that satisfy the inequality?
No.
Then what is the solution for this inequality?
Minus 2.
Minus 2 to
3.
3. Any number which in between minus 2 and 3, it includes minus 2. So we can say the solution x can be written as minus 2 to 3, this region. This represents the interval. Later, there is an explanation about intervals as well. So you can represent either this in the form of any real number from -2 to 3. Okay. So when you consider the second example, you don't have any factors. You can't see any factors over there. So you can't find the critical points straight away. What you have to do? -3 and okay. -2 and -2 and 3. Why we include that? Is that the question? Is that your question? Yeah. When you consider -2, what happens to this inequality? What happens to this side? Yeah. Yeah, but earlier we used to make this as an equal sign. Okay. Earlier we consider what happens if this is equals to 0. Yeah. Yes. Whatever, if we don't have this less than or equal sign, let's assume we have less than 0 instead of this. Anyhow, we have to take this as a 0 and take the critical points. Okay? Take the critical points and comes to the inequality and check whether do we have an equal sign or not. If equal sign is not there, then we can't include. Okay? Okay. Then, about this second example. Can you all factorize that? What is the factorization? X minus 4 and x minus 1 greater than 0. What are the critical points?
4 and 1.
Yes, 1 and 4. Do we need to include this 1 and 4 to our solution?
No. No.
No. Why is that? This doesn't equal to 0. Okay. Now what about the regions? Consider first region, second region, and third region. Yes?
First region we can consider 0.
First region, yes, we can consider 0. Any number which is less than 1. When we consider 0, what happens to this bracket?
-4.
-4. For this one?
-1.
-1.
All
-1. Altogether?
4.
4. It's a positive number. That satisfies the inequality, isn't it?
Yes.
Yes.
4? Yeah. Then the second region?
Take 2.
2. Okay. When you take 2?
-2.
-2. For this one?
1.
1. Altogether?
Yes.
-2.
-2.
Yes.
Is that satisfy the inequality?
No.
So we have to remove that. Next case?
5.
5.
1.
1.
4.
4. It is
4.
satisfied.
Again, it's satisfied. Okay. So this is the solution. Solution is -infinity to 1 doesn't satisfy the inequality. So we can't use the square bracket. Union, the knowledge of sets, okay, 4 and up to infinity. Always, when you are considering a region up to infinity, you can't write it as a square bracket. Okay, so remember that. We can't have closed bracket. We say this as an open bracket, and the squared one we call it as closed bracket. Okay, is that clear? Yes?
How to use bracket is not correct. Not understand this.
This part that I mentioned about infinity.
This part. This
part. Okay. Can we include the 1 for our solution? Is that 1 satisfy the inequality? No, that doesn't satisfy. So we have to remove 1 from our solution. If we wrote it as 1, this says minus infinity to 1, which includes 1. Okay? But when we are representing it with a normal bracket, this includes minus infinity, which is the 1 is not there in the solution. Okay? Like this. 1, if this is not a solution, then you have to have normal brackets. If we have 1, and if it's a solution, you should have square bracket. Square brackets indicate this element is also a solution. Okay? Is that clear?
yes, Mrs.
Yeah. Okay, if you have wrote your answers in a paper, can you please tell me a common way to find the solution if you have 2 factors? Without checking the sign, you can take it straight away. What is the solution for this? Which region that we have marked? For the first one? Yes? Oh, what is the solution for question number A? Minus 2 to
2 to 3.
3, this region.
3.
Okay. For the B, what is the solution?
Less than 1 and greater than
Less
4.
than 1, greater than 1, greater than 4. Here you have x minus 3 times x plus 2 is lesser than 0. So the solution is in between 2 and 3. Here x minus 4 times x minus 1 is greater than 0. So the solution is less than 1 and greater than 4. Okay. If you have less than 0 for only 2 factors, you should mark the region in between critical points. Okay. If you have greater than sign, you have to mark the region which is less than the lower critical point and greater than the upper critical point. That's all. If you have if you are doing many questions, you will identify. This will happen always if you have only 2 factors. Okay? Yes. Yes. Greater than? Yeah. If you are considering only 2 factors in the expression, If we have 3, that is different. Please identify there is a method also. Please identify that. If not, I'll explain it in the next theory discussion. I'll give you the hint for that on that day. Okay? So try it by your own. That's really interesting to identify the sign. Okay? And then if you have, earlier we had zeros in our right hand side. But in part D, we have a constant. Then if we have factorized the left hand side, is that correct? Yes? If we factorize, what happens? Can we made it equals to 0? You have to keep everything into one side. And after that only you have to factorize. Okay? So this case, you have to move this 9 into left hand side. That means x minus 4 whole square minus 9 is lesser than in minus 9. The rule that we have studied earlier at the beginning of inequalities.
-1.
So this is equals to 0. So that now you have to factorize the left hand side. Always you have to keep 0 in a one side. Okay, then also you can easily get the factorization. Okay, can you see this? This is the inequality after we are getting the factorization. After we are getting factors, this is the inequality. Okay. So you have to identify the colored regions. Okay. Then when you consider this kind of a question, first of all, this is not a linear one. Okay, this is not a linear one. So you have to do some mathematical operation for this. If A is a real number, okay, what can you say about the sign of A square? What can you say about the sign of A square? Yeah, it's a
Positive.
real number too. Is it
Positive.
positive or negative?
Positive.
It's always positive. So you all know that if you are getting if you are using if you are solving an equation, if you have this -2, it is equals to 0. You know that you can multiply both sides by x minus 4 and x minus 3. You can multiply both sides. But what happens to the inequality if you have multiplied both sides by this? Both sides by this denominator, what happens? Can we decide about this inequality sign?
No.
We can't say anything about that, no? Why is that? We don't know whether x minus 4 is a negative factor or positive factor. If it's a positive factor, it doesn't change the sign. But if it's a negative factor, it changes the sign. So we can't do anything if we don't know the sign. We can't multiply or we can't divide if we don't know the sign. So that But when you are using fractions, you know that the numerator and denominator can be multiplied by same factor. We will get the equivalent fraction for that. A over B is equals to AC over BC. Isn't it? A over B is equals to AC over BC. So we can make this fraction as same it is by multiplying numerator and denominator by x minus 4 and x minus 3. Now, when you have the equivalent fraction, you have x plus 1 times x minus 2 times x minus 4 times x minus 3 divided by x minus 4 whole square or times x minus 3 whole square. Okay? These two are equal. So, we have the same inequality sign over there. Now, what can you say about this? If we rewrite as this format, what can you say about this? Yes?
Not right.
Hmm? This is the same inequality. We just wrote the equivalent fraction. So someone says it's positive. In the chat, someone says it's positive. Which part is positive?
The lower
Okay.
part.
Yeah, lower part is positive. Let's say we have B over A. I'm saying that A is a positive number and this fraction is a negative number. What can you say about B then?
Negative.
B should be negative. So if we apply the same thing to our inequality, what can you say about this?
All is negative.
The numerator must be negative. We know that the denominator is always positive because we have squares in the denominator. So it's positive. So that to satisfy this inequality, always the numerator should be negative. So now we can rewrite the inequality as x plus 1 times x minus 2 times x minus 4 times x minus 3 is a negative number. Okay. Now you have to consider the critical points. Critical points are minus 1, 2, 4, and 3. So now you have minus 1, 2, 3, and 4. You have, since you have the equal sign, less than or equal, so these should be satisfied. Now consider any elements in between each and every region and think about the solution. Okay? Can you do this by your own? Yes? Yeah. Okay then. There are some other inequalities with modulus value. What do you mean by modulus value? Always return the positive values, yes. And if you have this kind of a inequality, what you can do? Yes. Can we decide about whether this side gives us a positive, the middle part? Anyhow, you have to get the solution for x. Whether it's a positive value, it's a
Yeah.
negative value, can we decide it?
Positive or negative?
Uh,
Excuse me, ma'am.
yeah.
Ma'am,
Yes.
can you show the line in the previous one?
Previous one. This.
We can't
And
use the black ball in the 3 and 4. We can't use the colored ball.
Sorry. Yeah. Sorry. Thank you for that.
3 and 4.
We can't. Yeah. Sorry. We can't use 3 and 4 because they are in the denominator. So if this includes in our solution, then this comes as an infinity. So that doesn't satisfy. Yeah. Thank you for pointing it out. Okay. Is that fine now? Yeah. Okay. Yes. What about this? How can we do this? Since we know that x minus 4, absolute value of x minus 4, if this is a positive number, then this is same as x minus 4. What happens if it's a negative number?
Four minus 6.
4 minus x, or in other words, minus x minus 4. Okay, either this will be a solution, or either this will be a solution. So we have to consider both ways. Then, if since we have only one inequality here, but when you consider both the cases, you can have it has two inequalities. X minus 4 is greater than 4, either minus x minus 4 is greater than 4. Okay, so once you multiply both sides by minus 1, the sign is changing. So minus x minus 4 is lesser than minus 4 when you multiply both sides by minus 1. So you have to get the solution for this inequality separately and then this inequality separately. Okay, so by this you will get x is greater than 8, and by this one you will get x is less than 0. Okay, these are the solution. X is greater than 8 and x is less than 0. There's another way to simplify that also. Can you understand how to simplify by considering two different inequalities?
Yes.
When you are considering inequalities, if you are taking the score of both sides, this inequality symbol won't change. Okay, because this side is also positive one. So this won't change. Then you can take the score for both sides. If you are taking the score, you can remove the absolute value. This is positive, square is also positive, so that this is always positive. Okay, and now take the factors. Now take the factors and decide about the solution. Okay, if you are considering x minus 4 whole square is greater than 4 square, so that you can have x minus 4 whole square minus 4 square is greater than 0. How to get the factors? Yes. How to get the factors? What is this?
Positive.
These are difference of two scores. Can we apply that thing to get the factors? Difference of two scores. How to get the factors for that?
A minus B and A
A
plus B.
minus B and A plus B. Okay. So that's what we have used here. Our A is equals to x minus 4 and B is equals to 4. A plus B and A minus B. Then we have here these two will be cancelled off. X times x minus 8. Okay. Now the factors are x and x minus 8 is greater than 0. The critical points are 0 and 8. This is positive, so these two sides. Okay. And someone asked about how we get x is greater than 8. I hope she's asking about this part. Okay. X minus, okay, let me erase first. X minus 4 is greater than 4. Okay. X minus 4, I'm subtracting 4 from both the sides. Sorry, adding 4 for both the sides in order to remove 4 from my left hand side. These two will be cancelled out so that this is x greater than 8. Okay. So that's how we are getting x is greater than 8 from this step to this step. Is it clear now? Yes. Yeah. Okay, then let me move to another question. Yeah, we'll see this question. Okay, when you consider this question, I hope now you all understand how to get the factorization if you have absolute value. Either you can take the score and perform. Okay. Anyhow, if you have performed either this way or getting the score, you will get x square minus x minus 20 or x square minus x plus 20. These two will be the factors. Can we factorize this? X square minus x minus 20. Can we factorize it? Yes. Yeah. What are the factors? The solution. What are the factors?
X minus 5 plus 4.
X minus 5 and x plus 4. Yeah. Now we know that we have solution for this. We can factorize it. What about this? Do we have any real solution for the second algebraic expression? When you try to get the solutions, you have x minus half whole square plus when you multiply This comes as 80 minus 1, 79 over 4 is this whole thing is equals to 0. Okay, so what can you say about this? Can we have real solution? When you try to do that, this is x minus half whole square is equals to minus 79 over 4. If this is negative, we can't have real solution. That provides us a complex solution. You have to find whether b square minus 4ac of this algebraic expression is negative or not. If it's negative, you can say straight away, we don't have any real solution which satisfy this. So you can neglect this inequality and work out with the first one. Okay, if you don't have a real solution, you can neglect that. Now you have to consider only x minus 5 times x plus 4 is greater than 0. Okay. So the solution is x is less than minus 4 and x is greater than 5. Can you understand why we neglect this inequality? Yes.
Can you just explain about it?
Can we have real solution for this quadratic equation?
No.
No. If not, since we are finding the real solution which satisfy the inequality. If you don't have any real solution which satisfy this second inequality, we can neglect that. The only thing is you have to mention why you are neglecting. If you have mentioned we don't have any real solution, that's fine. And remember that if you have something like the same thing here with minus sign, this has a real solution. Maybe that includes the square root of 79. Okay. Since this is a real number, so you have the real solution, then you can't neglect. But if you have, in this case, you have plus 79 over 4. When you move it into the right hand side, this will become minus 79 over 4, which is a negative number. So square of something won't be equals, square of a real number won't be equals to negative number. This doesn't satisfy with the real integer, real numbers. So that this doesn't have a real solution. Then you have to neglect it. Is that clear now?
Yeah, got it, ma'am. Thanks.
Okay. And then there is another question. If you have absolute values in both the sides, you can use either this way or you can take the square from both the sides and simplify. Okay. The same thing you have to do. Like this. Take the square of both sides and factorize each and everything separately, and then finally you will get the factors. Here this includes square root 6. It's a real number, so you can have the solutions. Okay, let me move to another kind of thing. Here we have x minus 2 divided by x plus 3. Absolute value of that is lesser than or equal to 4. Then the next step is multiply both sides by x plus 3. Is that correct? Yes? Why it's correct? If you are multiplying both sides, we have to think about the sign. Why this is correct?
Positive.
Yes, x plus 3 is, if we are considering the absolute value of x plus 3, so it's positive, then sign won't change. This is same as previous example. It's in the same format. So you can take the score of both sides. Okay. Here I am explaining some different questions in order to find the solution. When you are considering this, you can't have x equals minus 3 as a solution because it's there in the denominator. Okay. So likewise, then there is another type. Earlier we had only one inequality. But in this case, we have two inequalities. Okay. So first of all, you have to consider the solution for this. Okay. And the solution for this. Split this inequality into two different inequalities. Absolute value of x minus 3 is greater than or equal to 1 and absolute value of x minus 3 is less than or equal to 2. Get the solution separately for this one as well as this one. Okay. And draw the solution in a same real line. The solution for the first one is this is x is less than or equal to 2 and greater than or equal to 4. 2, 1, 4. I'm writing all the critical points over there. This first solution says this includes this part and then greater than 4. What is the solution for second one? Solution for the second one is numbers, okay, including 1 and including 5 in between these three. Sorry, I missed it over there. This should be changed. This is 2 and this is 1. Okay, everything including 2 for the first inequality and everything less than 1. Then what are the common region? Yes, what are the common region? Yes. You have to consider the solution of this and this one. By using the knowledge of set, you have to consider the common region. What are the common region?
2.
Common regions are this part as well as this part. Isn't it? The common region. So that the solution is x lesser than or equal to 2 and x greater than or equal to 1 and x less than or equal to 5, x greater than or equal to 4. If you have two inequalities in one question, you have to consider each inequality separately and the solution will be the common region. Okay. So is that clear? Is that clear? Yeah.
Yes.
Okay then. since the time is now 11:46, let me quickly go through this kind of inequalities. Here again, you have the same thing. And the right hand side, you have a constant term. You have to move it into the left hand side and simplify the left hand side. And then only you can easily get the inequality. Or else you can multiply both numerator and denominator by 2x minus 1. Okay. Then you can multiply it by this also. Make it as a positive and then you can multiply. Otherwise, you have to move this into left hand side and you have 2 over 2x minus 1 minus 1 is lesser than 0. Simplify this left hand side and then perform the remaining mathematical operation. Okay. And for the second example also, you have to simplify this. Okay. So simplify left hand side and make it as a simple inequality. And for the part C, you have to consider this separately. After that, this separately. There should be 2 different inequalities in one question. So you have to take the common region for that. Likewise, here also you have to move this into left hand side and then simplify. Okay, those are the main parts in inequalities. Do you have any questions up to now? Yes? Do you have any questions up to now? Yeah. Okay, then I have completed 2 sessions from unit 2. So you have to follow up the remaining 3 sessions. If you know the concepts of sets and inequalities, you can complete the session 8, which is a basic concepts of relation and function. There also we are applying the inequalities as well as the sets. Okay, then after that you have the polynomials, partial fractions. Those are simplification of algebraic fractions. And then after that, series part. Please follow up those 3 units as well before to the day school. Hope you all have the day school 2 problem sheet. Okay. Up to day school 2. Normally we are covering unit 1 in the first day
Recording
school,
stopped.
and unit 2 in the second day school, and unit 3 in the third day school. And the calculus part, we have 2 day schools. Calculus is your 4th unit. We have 2 day schools for unit 4. For the 4th day school, limit and derivatives will be covered, and for the day school 5, the integration part will be considered. Okay. So don't miss any quizzes during the day school. If you don't have power, please try to attempt it using your mobile at least. Okay. Then that's all for today. If you don't have any questions, shall I wind up? Do you have any questions? Yeah.
Weekend day school Saturday at 18 next day school. Weekend day school next day school Saturday 18.
18. Yes. You have enough time to study by your own.
Okay.
Okay. 18th is for weekend students and 20th is for weekday students.
Any exam we have?
Any exams are you mentioning about the CAT examination?
Yes,
Yes.
miss.
Sorry,
Yes.
yeah. CAT examination is there with the yes, this way. CAT examination is there on April 1st. Before that, you have
Okay,
to
miss. Thank you.
submit your TMA on March 11 or no before March 11. Okay.
Have you exam before CAT or TMA?
No, there is no any exams. You have the final examination on probably October.
Online quiz?
Online quizzes means there are 9 online quizzes for this course. There will be informed at the end of each day's course. These are not day school, these are theory discussions. The day schools will be on Saturdays and Mondays. I hope you all received the activity diary in learner support. You all have that.
Okay.
So please refer to that. For at the end of your day school, your teacher will be announced about the quiz. For the OCAM mark, we are calculating best 5 quizzes out of 9 quizzes.